We will just give him maybe 1 more minute. Otherwise, we'll get started and I'll just take over. Right, everyone. It looks like Daniel has not been able to fix his tech issues. I can hear a bit of an echo from me. One sec. Can you hear me now? Yes. Can I get a thumbs up if you can hear me? There's the reaction buttons on the bottom. Okay, excellent. Thank you very much. So let's dive in. Um, so I guess for starters, can we can you tell me if you have any questions from last week? If there's anything that's immediately burning questions that you would like for us to address. All right, Olabisi, please go ahead. You have your
No,
hand raised.
I don't have any. I was told that I can hear you.
Okay, great. So there is that. You can click that. Yeah, excellent. Thank you. So I'm just going to share my screen so that we can get started. So first of all, can I also ask if all of you have downloaded R and have at least taken a look at it? So maybe a thumbs up if you have. Okay, excellent. So there is the reaction button on the bottom where you can click say thumbs up or thumbs down, whichever it is. Um, okay, thank you. I'm going to try to zoom in so you can see my screen better. So one question that I have is this. Can you tell me if you can see my screen okay? All right, good. So I'm just gonna okay, I'm just gonna dive in and say that for many of you this might be the first time that you're coming across R. and R Studio. And basically, so R is a software that we use for statistical analysis, and R Studio helps us to use R in a way that's more user friendly. R is essentially code based. It's just lines of code. It looks like Notepad, but R Studio helps us to format the code in a way that's easier to use. Teniola, you have a question? Okay. All right. So R Studio helps us to format that code in a way that is easy to use. Um, and and so we're really, when we say we're using R Studio, for me personally, I find R Studio is the easiest way to use R, and generally do not use I generally do not use R per se. Okay. I just focus on R Studio. So if you have downloaded R and R Studio, you only need to use R Studio to function. R is just in the background doing all the work. Okay. So when you download R, your R might not look like this. It might have a whitish background, and you can edit that the way the R appears. I believe it's in let's see. You can edit the way R appears somewhere. I don't remember off the top of my head now, but I prefer this dark mode because it's easy to, yeah. So here, so you can edit this in panes and you can change the appearance, and that gives you more flexibility. If you want to go back to the basic white R Studio, you can. I'm just saying that don't be scared because this has a black background. Okay, it's just easier on my eyes. So the next question that I have for you is this: have you played around with this code, and do you have any initial reactions, any initial questions? No. Okay. Anybody who has played around with the code and has any initial questions? All right. So let's get started.
Please,
So
where can we access the code? So sorry, this is my first time joining the class.
okay, great. The code is in the Google Classroom. Do you have access to Google Classroom?
Yes,
Okay,
I
good.
do.
So if you go to Google Classroom and you click classwork, okay,
Okay.
Measures of central tendency. So for each topic, we have the R code that relates to that topic. So we're starting with the one for measures of central tendency because we didn't have an R lab last week. Okay.
Okay, thank you.
Yeah. So
Yeah, please, I want to confirm, is the class recorded so we can replay it and watch over later on?
yeah. So the class is being recorded. Sorry. Okay. So the class is being recorded, and you can download the R code from here. So this is the R code and really we already have videos that have walked through everything that we're going to show you today. Okay. So if you might not even need this recording per se, but if you want to go faster, you might be able to go online and download this YouTube video and or watch the videos that are posted. And this is the R code, it's the exact same thing. Okay.
Okay, thank you.
Yep. So back to R. Let me open the code. Okay, so you have this code R Lab 1, right? Everybody does. So basically, I've introduced R to you, and really, what R and R Studio are used for in most commonly is for analysis, right? But we can also use it for other things. You can use it to
Sorry,
manage.
sorry, please. I think I have a problem.
Yeah, what's the problem?
Okay, I clicked on the R Studio. It wasn't opening. It was like R showed on my screen for a long time now. It wasn't opening.
Okay, can you share your screen quickly? Let's see.
Okay. I don't know. Can you see it?
No, we cannot. There's that present now button on the bottom. How's it going, Ibuka? Are you still having trouble sharing?
Okay, I'm sharing now.
Can anybody else see a screen? Okay, great. Yeah, it's coming on. Very good. Okay, can you click got it so we stop seeing the, yeah, okay, good. So if you show that, so this is your screen, where's the R? So you click R on the bottom. Yeah, click that.
On the Google Meets.
No, this is fine. So basically, I don't know why it's taking so long for you. Maybe you need to restart your computer. Because ordinarily when you open the R, it shouldn't take so long.
Sorry, sir. Please, sorry, sir. What
Yeah.
are we doing now?
I'm
Is-
just helping him troubleshoot quickly.
Okay,
Yeah.
okay. It's different from what we did in the afternoon.
Yeah, it was different from what you exactly. So what you did in the afternoon was SPSS,
Okay. So what are
and
we?
this is R.
Okay, okay. Thank you.
Okay. All right. So it's basically the same thing in R.
Sorry, I
Let me
encountered the
understand.
same issue, and what I did was I went on YouTube and I found that if you click your control button and just press it down, then click your R, it might work that way.
Okay, you can try it out.
Okay.
Like press your control button down and then click on that R button.
Yeah.
Yeah.
I think you should restart your computer.
Okay.
So
Actually,
this
it's working.
came on, yes. Then you click on something, okay, and then it will come on.
Oh, you have multiple versions of R. Okay, click OK.
Okay, I've clicked.
All right,
OK.
so yeah, so unfortunately we don't have a lot of time and we will not be able to
Thank you.
do a lot of troubleshooting in the class. Renee, please. Question.
Yes,
You
how
have a
to
question?
access Google Classroom?
So let's talk about that. Can you send an email and we can set up time so that we can talk about that, please? Okay. All right. So let's get back to R. So if you have this R Lab 1 open, do you have it? Does everybody have it open?
Yes.
Thumbs up if you have R Lab 1 open. Okay, if you don't have it open, yeah, I see if people are having trouble with it. So if you don't have it open, can one person unmute themselves and tell us what they think might be the problem? Do you have access to Google Classroom? Because if you don't have access to Google Classroom, yeah, so the display might be different.
Okay, I think what I have in my own it was showing me the R version, this. It wasn't actually showing me how your own was arranged.
Yeah, so you should now click File. Okay. So if you have downloaded that R Lab 1 file on your computer from Google Classroom, okay. So first then download the file on your computer, then click File and open that file from where it is. Okay. So if it's in downloads, for instance, you can double click it here and it will open. I'm not double clicking in mine because I already have it open. So if you double click it, it will open. And that's all you need to do. You click Our Studio and okay. All right. So the interface might look different, but we're going to walk through the interface in a moment and you will understand. Okay. So the first few lines here just tells you about how to install R on Our Studio, which is something that we already went through. Okay. And as I was saying, I said that we use R for analysis, but we can also use it for other things. You can use it for data management. So if you have a clinical trial or you have a study and you're trying to rearrange your data in some forms, you can use R for that. On a daily basis, this is what we will typically use R for. Okay. And then if you're doing an analysis, you can use R for the analysis.
Dr. Abiy, sir.
Yes, hi.
Oh, I'm back now.
Okay. All right. So you want to take over? So I'm going to start sharing my screen. I haven't started really, just still setting up. So we're here talking about so now we're going to talk about the console and the different parts of this Our Studio.
Okay. So I'm very sorry. I have some slight challenges with network, so I could not meet up with the timing of the class. So let me start sharing my screen. Start sharing my screen. Come on. Please, can you confirm if you can see my screen?
Not yet, we cannot.
No, we can't.
Not yet.
So can you confirm if you can see my screen?
Yes, we can now.
Oh, okay. So the aim of today's R section is just taking you through the introductory part of the R Studio and R itself. And overall, at the end of this section, all the section for this course, we are going to learn data management, data analysis, and data visualization. So, and also resources, like there are some resources that Dr. Abiy and the team has already coupled together to help you strengthen your programming skill and your statistical skill. So please, can you hear me clearly?
Yes, we can hear you.
Okay, good. I think by now everyone should have like installed R. Everyone should have R Studio on their system now, on their respective system by now. So I'm going to like take you through the environment. I'm going to take you through the environment, all the overall environment before we start into the class proper. So since you can see my screen, at the upper right of our studio, we have the environment. This is where we have the environment. Once you assign a value or vector to some values, it's going to appear in the environment as well. We have the history there, as you can see. We have the connection and tutorial ECT, but this is generally called the environment. At the right hand side, at the bottom right, we have the files, the plot, the package, help, and view, presentation. And so when we get to the lesson, like you are going to know what those things are actually for. So at the bottom left is where we have the console. So this is the R console. So R console is where you run your codes. You run your code in the R console. And at the top left, we have the script panel. This is the script panel. Let me just make it bold. So this is the script panel. Like majorly when you start programming, you have to spend most of your time in this script panel. Most of your time, you're going to spend it in the script panel. So mathematically, the first quadrant is the environment, the second quadrant is the files, plots, package, help, and view view tools, while the third quadrant is the causal, and the fourth quadrant is the R script panel. So that's how it works. So now let's go into the class properly. So I think everybody should have this software on their system by now, because there are some resources we shared earlier before the R section. So I've talked about installing. Actually, installing is okay by now. If everyone has installed, so I don't really need to talk about installing. So for anyone that has not installed the R Studio, R Studio is very, very easy to install. It's a free open software that you can just download and start using in the twinkle of an eye. So let me just start with writing commands and executing commands. I made mention of script panel, which is where you spend most of your time like trying to code and all this stuff. So you spend most of your time in the script panel. So this, don't be confused. Don't be confused. I'm coming. Let me try something. Let me show you something. I'm coming. I'm coming. I want to show you something so that so this one, this script pan, this script we shared is an R markdown file. So it's an R markdown file. When we get to the area of R markdown, I'm going to explain R markdown properly. So this is how a script, like a proper R script, looks like. This is how a proper R script looks like. So when you press enter, you have new line of code. You have line of code. You see it keeps on bringing the code lines. So this is how a proper R script looks like. So don't be confused when you see something like this. This is just an R markdown. So I'm going to explain this better in subsequent sections. So now what we talk about assigning value to variables. So it's just as, let me just say, when you say x equals to 2, what you can see here actually is x equals to 2. This is what it means. This lesser than and a dash is called an assignment operator. So it's called an assignment operator. It is called an assignment operator. So you are going to see this. It's just same thing as just writing x equals to 2. It's just same thing as writing x equals to 2. But in R, let me just say in R, once you write x equals to 2, like a professional we know, like you are just a novice, like when you start writing x equals to 2. So it's improper in R. So you have to use assignment operator, which is x lesser than an hyphen 2. So once you run on R markdown, if you want to run a particular code, like now we type x equals to 2, x, we are assigning value of 2 to x. We are going to use Control and Enter to run that particular command. Do you see that it did not display anything? The reason why it did not display anything is like we are storing that data in a particular variable. So we are not calling the variable. So on the other hand, can you see this 2 plus 3? If I just click Control Enter, we are going to see 5. That is, I'm doing an arithmetic operation. I'm performing an arithmetic operation. So you are going to see 5. You're going to see 5. So because I did not save this to a variable, that's why it's showing the endpoint result. But this, I'm saving this to a variable. So you are not going to see like endpoint result. I'm telling R that value 2 is assigning to x. So anywhere I reference x is going to bring 2 automatically. So we are assigning the value of 3 to y. Once we click y, you're going to see. So once you come to the environment, can you see? It shows value x 2, y 3. So that shows that we are assigning values. We are assigning values to variables. We are assigning values to variables. So that's it. So once you want to get your x, you just come to the R and you say x. It's going to show you that x is 2. Once you click your y and run your y, you're going to see it's going to tell you y is equal to 3. So once you say okay, x, let's see what x plus y will give us. It's going to give you 5. That's 5. Okay, let me now say I want to make x plus y. X, okay, let me just say z assignment operator equals to x plus y. You see, it's not going to display any result because I assigned the summation of x and y to the value of z. So it's not going to show any endpoint result. But if I want to call out the value of z and I just write z and run the script, the code line of z, you're going to see it's going to bring the value of z. So and then assigning this value to assigning your value to your value to a particular variable. You can do it in an other way around. Something about programming is that it's not it's not rigid. Yeah, it's very, very flexible. You can see someone just say, okay, for assignment operator equals to d. This is also an assignment operator. Can you see it's changing because the value came first in this case, and the variable name is coming last. So the assignment operator becomes greater than an hyphen. The value hyphen greater than d. But if the variable is coming before the value, we are going to have the variable lesser than hyphen the value. So I think do we all get that? Do we all get that? Like, do we get that? Do you get the explanation?
Yes. I get that.
Okay. So we can
Please,
move
how
on.
are you thinking?
You said
The
the operator is just
for those.
okay. The operator is just your normal lesser than. Okay, I'm coming shift lesser than and hyphen very close to your 0-digit number on your keyboard. That hyphen, just hyphen lesser than an hyphen. So do you get? Can we move on?
Please, can you from that your z lesser than hyphen x plus y? What were you saying? I don't understand from that place.
Okay. I just bring another scenario. I'm telling you that R is not rigid. That you have to follow a particular algorithm. No, you can twist things. Like this is let me just say this is the proper way of assigning a value to a variable. X lesser than hyphen the value. But other way around, if you want to assign the value of 7 to d and the value is coming first, you are going to hyphen and greater than d. It's also that you are telling her that wherever is cd, it means 7. I don't know if you get that.
I get this part, but when
Okay.
when you put x less than hyphen 2, you will see it on the environment wherever R sees x, that means 2. Then y less than hyphen 3, wherever you see y. Then when you go to that place where you did x plus y and you put control enter, it will give you 5. But this z less than hyphen x plus y, when you put control enter, it won't show you anything. And then when you come and put z,
I got your answer question now. Do you know this one is not showing you anything? Because you are telling her that z is the summation of x and y, which is 5. So you are storing that 5 into the variable called z.
Okay, I understand.
So can Can we move on?
Yes.
Okay. So now, performing basic operations, like I used to tell people, you don't really need calculator to perform basic operation as far as you have R, because anything, come to think of anything you want to do, arithmetically, statistically, mathematically, R is there for you to do the operation for you. So 33 plus, we've already provided some codes which are very, I'm just going to take you through the codes. I'm trying to take you through the codes. So 33 plus 7, you're going to see the value. That's 40. The reason why you are seeing this 40 is because we are not assigning the summation of 33 plus 7 into a variable. I don't know. So we are not assigning this, we are performing basic operations. We are performing basic operation. This basic operation you are performing with these numerical values now. You can also perform them with these variables, because you have already set some certain value to equivalent to some variables. So now 33 minus 7 is going to give you 26. 33 times 7 is going to give you 231. 33 divided by 7 is going to give you 4.71. Okay, let me just say approximately 4.71. So what is the square root of 33? 5.74. The log of 33 is 3.49. What about the exponential of 33? Is 2.14. So you can perform a lot of arithmetic. You can perform a lot of arithmetic calculation and basic operation, math operation with this R. So let me give you an extended one. Let me just say, okay, 33 plus 7 minus 12 times 2. Can you see? It's giving me 16. It's giving me 16. I can still go as far as I want it to go. I can still like expatiate it. I can still say, okay, plus log of 33. So it's going to give you the value. So these are actually basic operation. So like you know your addition, which is plus, you know that you are plusing two or more or three coefficients together, that is you are summing them together. You know your subtraction, that is you are minusing a particular coefficient from another coefficient, two or three coefficients. You know your multiplication, you know your division, you know your square root, you know your log, you know your exponential. It can do inverse. Let me just say 1 divided by the log of 33. It's going to give you answer. So as far as you know your basic arithmetic, you know what you want to do, so you can easily do that. I think we are cleared in the area of basic operation.
Please, I just have one clarification. So each time I press enter after a particular equation, it just takes me to the next line. Also bring out the answer. I don't know if I'm doing the wrong thing, please.
Yeah, if you press enter, it's going to take you to the next code, to the next line code. You see that those lines, those code lines, they are numbered. Can you see?
Yeah, so I want to get
numbered.
the answer of the equation instead of
So you are going to click control enter.
Okay.
Control enter. So just try that now.
Okay. Yeah. Thank you.
So are you getting the result now? Okay.
Yes, thank you.
So I've explained assigning variables to value, so I don't need to explain that again. So now, a very important note, like you have to take note of this. If you are trying to use a variable that is not in the workspace, that is the environment region, you are going to get an error. You will definitely get an error. Okay, let me just say I did not assign any variable to J. Let me just use the word J. I did not assign any variable to J. I just like, okay, I now come to R and come and say, R, give me the value of J. We're going to say object J not found. Do you know this is why object J is not found? Because I have not assigned any value to object J. to variable J, actually, not object J. I've not assigned any value to object J. So I think we all get that. So if you do not have a particular variable, like a particular value assigned to a variable, you will never see it. You can never find it. You keep
Sorry, Daniel,
banging errors.
Sorry, Daniel, I think we have two raised hands. I don't know if Ada and Zaya still have questions.
Okay, sir.
No, sorry, he has answered my question already. Thank you.
Oh, okay.
Yeah, same for me. Sorry about that.
Okay, thank you. Please go.
Okay. Is there any question again? Can we continue?
Yes.
Okay. So if you want to view your objects, the objects you have in your environment, in your workspace, which is the environment region, so you don't need to come to the environment and come and check the number of objects you're having. Now we're having 3 objects, we're having X, Y, and Z. So you don't need to come like that. You can just use a function called LX into parentheses, like you open the bracket and close the brackets, then you click enter. It's telling us that we have X, we have Y, and we have Z. So another way, if you don't want to, like, if you think clicking Control Enter is stressing you, just come to this end part. You are going to see run current chunk. Run current chunk. So once you click on run current chunk, it's going to run the code automatically. So deleting the variable from a workspace. Okay, let me just say I don't need the sum of X and Y again. I don't need their sum, which is Z. I don't need their sum. I will just come here and just use the function rm into bracket the name of the variable I did not need again. I did not need Z again. So once you run the code, it won't show you anything. But once you come here and said, okay, give me the value of Z, you see object Z not found, because I've already eliminated Z away. I've taken Z away, or actually taken it away. So now we are now going to vectors. We have something we call data structure in R. Data structure in R. So which one of them is vector? Vector stores the same element, the same element type. It's stored the same element type. You cannot, like, okay, I want to store a vector now. I want to store a vector. I'm now missing numerical variable with qualitative variable. It won't. Like, I'm mixing it in the same vector. It won't. So it store values of the same type, value of the same type. So imagine what vector actually works for. Let me just explain this before we go proper. So imagine we have 10 students and we take the height of 10 students. We take the height of 10 students. So I want to put I want to assign the height of 10 students to a variable. So I said h1 equals to, probably the height is 1.78. h2 equals to, that is height of student 2 equals to 2.0. Please, if I start repeating this thing, like assigning them to h1, height1, height2, height3 till height10, what if I have like thousands of data? Can I perform that for thousands of data? It's not possible. That's the reason why the idea of vector came in. The idea of vector came in. So once you have a vector, you can tell R that, okay, this height of this student, I'm putting them in this vector. That is, I'm combining the height of the student. Once you have a vector, you are going to see this small c. Like, this small c is mean combine, like you are combining series of data or values together to form a vector. So now we have a vector 1 consisting of 26, 7, 4, 5, and 8. So you are telling how that vector 1, your assignment operator, combine value 26, value 7, value 4, value 5, and value 8. I don't know if you get that. So that's what vector does. Okay, let me just say we have age of student, student now. Student, I want to put them in a vector. The first person is 12, the second person is 15, the third person is 17, the fourth person is 16, the last person is 20. Okay, I'm telling how that the age of this respective this student is 12. One of the students is 12, another one is 15, another one is 17, another one is 16, and another one is 20. That's what I'm practically telling her. Instead of me assigning it one after the other, it won't. I just combine everything together. I combine all the values together. So this vector now, once you run this current code, you are going to notice it's not going to bring any value. The reason why it's not bringing any result is that we are storing these values into vector 1. These respective these values, we are storing them into vector 1. So wherever you call the function of vector 1, you call vector 1 vector 1 outside, you are going to see the value. You're going to see the value. You're going to see the value. I'm just showing you using vector. It can be age of student, it can be height of student, it can be name of student. It can be name of student. So let's move to vector 2. I'm coming, let me tag this one. Let's move to vector 2. So this vector 2 consists of, I said something that vector store data of same type. But I know somebody might want to ask, why is y numeric? Because we said vector 2 is combination of 1, 3, and y. Someone might want to ask that why is an alphabet is an alphabet? What is an alphabet doing in a numeric data? We have already stored the value of y at the beginning of the section. We said y equals to 7, right? Y equals to 7, right? So once you run this vector 2 code and you call the value of vector 2 out, you are going to see it's going to bring the value of what you use to store your R. You are going to see it's going to bring the value of what you use to store your Y. So that's how it works. That's how it works. So combining two vectors together, you have, okay, we've stored vector 1, we've stored vector 2. So I want to form vector 3. I want to make vector 3 the combination of vector 1 and vector 2. So it's still the same procedure. Vector 3, assignment operator, combine vector 1 and vector 2, comma vector 2. So once you run this line chunk, you are going to see, and you call out vector 3. Once you call out vector 3, you are going to have the old value. That is, you are telling how that this vector 1 value is the this vector 2 value is the continuation of vector 1 value. So it's going to join all the values together. It's going to join all the values together. So what about when dealing with non-numeric data? Let me just say when dealing with let me just say name. So name. Okay, let me just say name of student. Assignment operator, combine. You have, let me say the first person is Dan. The second person is T. The third person is AY. The fourth person is D. So do you see I put those names in quotations when dealing with a qualitative data. Let me just say qualitative data. And you want to assign a qualitative data to a variable. You are going to put them in quotes. So you are telling R that this is a character data, that it is qualitative initial. You are going to put them in quotes. So when you write on this code chunk and you call out the name of students, and run it, we are going to see it's going to bring the names of students. We are going to bring the name of students. So I hope all of us get that part. So do we all get that part?
Yes, but I have a question.
What is that, please?
Yes, my question is, when you started with the height, the example of the height of maybe students, you said it will be too cumbersome. Supposing you have like 100 heights that you want to enter. But when you are giving your example, you wrote 26, this, that. How did you get that 26? Is it not that you typed 26 one by one, 26, 1, 7? So if you have like 102, it will still be cumbersome like what you are trying to run away from.
Okay.
Then my second question.
Okay.
Yeah.
I got your question.
Yes. My second question is, when you are combining vector, if you say combine vector 1 and vector 2, it will bring those figures in succession like that. Can you do combine vector 2? Can you write vector 2 before vector 1? And it will
yes,
bring
you can obviously write vector 2 before vector 1. You can place it any way you like it, but depending on what you want to get.
Then when the result came out, there's no way you can know which value is meant for each of those vectors, except you look at what you combined before you can say, okay, this 26 is for what, this 2 is for this.
Actually, if you notice what I was saying is that once you combine vector 1 and vector 2 together, you are telling R that, oh, vector 1 is incomplete. Let's assume that the vector 1 is the height of let me just say 20 students. Vectors is the height of 20 is the height of students. So vector 1 contains 15 students. Like we mixed 5 students. Later we now realize that 5 students are missing, and we get their respective heights. We now created another vector, which is vector 2. So combining vector 1 and vector 2 is telling R that, hey bro, this is the remaining height of the students that were not captured in the vector 1. So I don't know if you are clear.
No, it's not clear. What I'm saying is that in vector 1, you wrote 26, 1, 7, this. You wrote those figures one by one there.
Wait.
But you were trying to run away from writing those one by one. That was why you wanted to combine. But eventually you wrote it one by one. Is there any way we can say, okay, this 100 students with this different heights, is there a way we can write it in a short way that we can get all the heights, instead of writing the height of 1, height of number 2, height of number 3, height of number 4, up to 100?
Wait, we are still getting there. Do you know this is why I actually make an illustration of height 1, height 2, height 3. It's telling you the importance of vector. I'm telling you the importance of vector. It's like having like 10 students now. You have their height. You now start saying
Yes.
H1 equals to the first one, H2 equals to the second one. It's like stressing you. So, but when you create a vector of height of students, you are just going to your assignment operator combine and you put the whole value of the height. I don't know if you get that.
I did. So eventually we are still going to put those values of each of the individual heights.
Exactly. You are going to put them in vector to get them in a single vector, not in a separate variables.
Okay. It's okay.
So are we cleared?
Yes, I'm okay.
Question, please.
Okay. Can you shoot, please?
Yeah, it's still on the vector. If you have data that is up to 1,000 and you don't really want to start typing these things one after the other for you to get to put in the heights for 1,000 people, right? How do you get past that on this software where you don't have to manually type in those figures?
You know something. You know something. Behind any data analysis or statistical analysis, there is a way the data is originated from. So we are still getting there. It's either you have a data entering clerk that's going to do the entering, or you have those data in another file that you are going to import. We are still getting there. I don't know if you are clear. Like we have some people that their work basically is just to enter data. That's their work, is to enter data. That's their work. They don't have any other work.
But we can import files onto this software, right?
Exactly. So having your data in Excel, SQL, or whatever SPSS, you can just import it. We are still getting there.
All right. Thank you.
Hello.
Hello.
Yeah. So
Hello,
thank you so.
Hello.
Yeah. Should I ask my question?
Yeah.
Yeah. My question is I understood you that you are saying vector. We are assigning we are writing all the heights, for example, but we are just grouping them so that we are not writing a height 1, height 2, height 3. So what if maybe a name is important for each person so that maybe we can trace him or we can identify that person later. So instead of grouping them as vector without assigning name to each one, so how we can trace another person to say, okay, Joy has maybe a height of 33 and later we can look for Joy among the.
Okay. Okay. Just this your question. Can you just hold this your question?
Okay.
Just hold this your question. And just give me in the next 5 minutes. This your question. You will answer it yourself.
Thank you.
Just hold this your question. Please, anybody else? So I think we can move on. Okay. I can hear you.
Yes, sir. You mentioned something about calling out names of students and running it. I'd like to ask, what was how were you able to run the code when I think you selected that line code and you pressed something. I just want clarification on that.
Okay, what I just did is that after assigning the name of students, after assigning values to the name of student, what you don't have to do anything, just to write name. You see, this is the reason why R Studio is very, very important. It's going to suggest. You see, it suggests to me that, okay, did I want to really call name of students? Did I want to call out a function? Did I want to do something? I don't know, you get. You can just click name of student and you just run your code. Then you have your names.
I understand now, sir. Thank you, sir.
Okay. So can we move on? We are really behind time. Can we move on?
Yes, sir. Move on, sir.
Yes.
Okay.
Yes.
Okay. So the next data structure I'll be talking about is list. So list is a data structure that is very convenient for storing data of different type. I know during the course of the week, you guys have taken your, I think, if not your first and second class, that you might have talked about qualitative variables, quantitative variables. The way we have qualitative variables and quantitative variables, that's how we have qualitative data and quantitative data. We have discrete, we have continuous. So this list is capable of taking, of absorbing any any of absorbing any data of different structure It's not like it's not like vector that is limited to only same structure and all this stuff. So here I have a list of data. So once you want to use a list, let me just say you want to use name. Okay, let me just say v1 equals to, you are going to call a function called list. That is, you are telling how that this data I'm putting inside you, this data I'm storing in this particular variable is a list. It's a list, is in list structure. So that's it. So we've already bring out a particular code for that. So we have list underscore data. Assignment operator list. We have red, we have green, we have a vector. Can you see vector? This is a vector. Vector 21, 23, and 11, and 32 and 11. That is combining those three values together. So then we have a logical statement, which is true. We have integers. So can you see? So we combine series of data together, series of data types together. We combine them together. So when I run this and I call out list underscore data, you're going to see it's going to bring all what you've run. Can you see? Red, green, the vectors, true, this and this. So that's the list store data type, different data type. So, and then, pardon my manners, when calling out, you can call out a name of a particular variable in two ways: either writing the name of the variable and clicking Control Enter, or using the function called print. And I say print, let me just say print vector 1. I'm calling out vector 1. It's going to bring vector 1 values. So please take note. Is that you use print or you call out using the variable name? You use one of the two, please. So that's what list entails. So creating two lists. So we have list 1 to be numbers, to be 1, 2, 3, and we have list 2 to be days, which is Sunday, Monday, and Tuesday. So once we want to just combine them the way we combined those vector. So we created another variable name called match.list. Match.list. This is just like giving a variable name. You can change it to match underscore list. You can change it to match list. As easy, as convenient as you can name your data, so that you can remember so that you can remember your variable names. So you should name your variable names the way they'll be very simple for you to call out. So we are telling how that matched list assignment operator we are combining list 1 and list 2 together. That is, the information in list 1 is incomplete, so we are adding list 2 with source for another information together that should be in list 1, but it's not in list 1. So we are adding them together. We are bringing them together. So once you run this particular code and you call out the function of list, so once you print it out, we are going to see it's going to bring all the values. It's going to bring list. It's going to bring 1, 2, 3. Sunday, Monday, and Tuesday. So please, are we cleared in the area of list?
Yes.
Okay. So I think we can move on now. We can move on now. So we have another data type
Sorry.
called hello.
Sorry, please. I didn't really understand the list part.
Okay. The list part, the list data structure is used to store variable of different type or data of different type. So let me just go back to the list. Let me show you something. Can you see? This is a qualitative variable. That is giving attributes to color, red and green. And here again, we came and insert another vector which is quantitative. 20, it might be age, it might be anything. So we insert another vector, and we insert another data which is called logical statement. Logical statement. True and false is logical statement, if and all this stuff. And we still come again and put continuous variables. So list helps to store, like if you have like different data, and you want to store them, different data of different structure, you can put them in a list. So that's what list does. And once you look at this place, we have a quantitative data at list 1. Then list 2 again, we're having a qualitative data. We are merging the two of them together to form a single list. When I like call out the function print list, print match list, can you see? It brought out the whole list 1, the whole values in list 1 and list 2. Because list, what we are doing after when merging two variable or two lists together or two stuff together, is like we are telling out that this value can be this data set can be completed if these two lists come together. Like in the first list, we have missed some information, and in the second list, we have missed some information. Without the first list, the second list is not complete, and without the second list, the first list is not complete. So I don't know if you get that now.
Yes, but you only wrote merge list. You didn't say merge list 1 and 2.
Okay. Can you see here? We said match.list assignment operator combine list 1 and list 2. Then I run it. It's not going to show any value because I store them in the variable name called match.list. So once you call out the function of match.list, that's when you're going to see your values. Once you use the print or you just use match.list, can you see? And you run it, you're going to see your value. So are we cleared?
Okay.
Okay, sorry. Please, for me, I'm trying to list it, but it's showing error, unexpected symbol.
Unexpected symbol.
In the list
Then,
data.
are you okay? Wait, are you using this particular R script?
Yes, I'm trying to follow what you're doing. Yes.
Okay. So where is the writing error? Is it the first list or the second list or the merge list?
No, the very first list.
This first list?
Yes.
Okay, confirm you have list 1 assignment operator list 1, 2, 3.
The thing with code is that if you even make one tiny mistake, you might run into trouble. Like even if it's a comma that becomes a full stop, right? You might not get the results that you want. So you need to check carefully, or you make sure that you copy what's exactly in the code and try it again, especially if you've been able to run the previous code.
Okay.
So one of the important, let me just say key attribute of R is that any slight error, probably in spelling, probably I save my variable to be variable 1 and I use initial cap. And when I want to call out to that variable 1, I use small letter, like to small letter as the starting. VAR, small letter VAR. You see, it's going to bring error. It's going to bring error. So R is very, very sensitive to objects and to mistakes. It takes note of every bit, everything like that. It takes notes. It's very, very sensitive. So you have to be very, very careful when exactly when writing your code. You have to be very, very careful and very, very sensitive. So I think so. Can you just run that? Can you run that? Have you spot yourself?
Yes, I've gotten list 1 now.
Okay, run list 2 too as well. Is it working?
Still on it, please. Yes, I got list 2.
Okay. So can we continue?
Done. Thank you very much.
Okay. So, so now going to a factor data structure. We have factor data structure. We call them factor. They are just like data structure. So factor, when dealing with categorical data, we have something we call categorical data. They are in categories. One cannot come before one, and another. Okay, one can come. They are in, like they are in a structured manner. Let me just say they are in a structured manner. They are in a structured manner. They're in a structured manner. Example of category variable can be okay. Let me just say cancer type. We have stage 1 cancer. We have stage 2 cancer. We have stage 3 cancer and stage 4 cancer. I don't know if there is 5. So, like you are going to see them in either in an orderly manner. So we call them categorical variable, categorical data or variable, as you will all call them categorical data. So they are in categories. So factor help us to store data as category variables. It helps us to store data as categorical data. So now I'm sorry, I'm going to deviate. I'm not going to use, okay, let me just make use of this example. So we have sex. When you want to store a factor variable, once you call out, let me just say cancer underscore type assignment operator factor. So you are going to use the word factor. I'm going to use the word factor because you are telling her that, oh, this thing I'm putting in you is actually a factor. So once you open, we are going to combine. That is, you are combining them together. You are going to open another bracket, combine. You see, I'm putting like I'm okay. Let me just come in. Let me just do it this way. Okay, I'm telling her that, okay, this data is a vector. Cancer 1, we have stage 1, we have stage 1 again, we have stage 4, we have stage 3. Okay, let me just put one stage 2. We have stage 2. So if I run this like this cancer type code chunk and I call it out, if I check the structure, it's not going to bring a character that is showing that it's just ordinary qualitative. It's just qualitative, like no structure. I just gave them no order, nothing. I just give them like, okay, these are the stages of cancer, no structure. But once you are like attaching a factor function to it, You are telling R that, hey bro, this data is they are in structure, they are structurized. That is, they have orders. So they have orders. You are telling R that they have orders. So when creating okay, let me just go by just putting enter. So once I create enter and I call out the levels, okay, I want to check the number of levels cancer type is having. It's going to show you that it has 4 levels, which is stage 1, stage 2, stage 3, stage 4. It's going to like arrange them by their levels. It's going to give them like the structure they are ought to be. That's what factor does. It's going to like give the data structure. When we are talking about, let me cite a very good example. Which one? Okay, when we are talking about disagree, okay, let me just say strongly disagree, undecided, agree, and strongly agree. So they have a structure. They have structures that they are ought to be. They are ought to be. You cannot tell me that someone progressed to a stage 2 cancer. Hello. You cannot tell me that someone could get to a stage 4 cancer without passing through 1, 2, and 3. So they have a structure. They have a structure they follow. So when creating it, you can just come here again. Probably after you want to tell. Okay, I'm hearing you.
Okay. When it comes to issue of factor, are you trying to say that when we factor X to cause a rearrangement and it grades from lower to higher, or maybe alphabetically? Is that what you're saying? And at the other end of it is, if we want to check what we have created a factor for, we use levels to check it.
Okay.
I want to know if that's
okay. Factors.
I have a comment.
Please, can I just through, like, when I'm through with that, you can just throw your comments, please. Or is it regarding the question?
Okay.
No, yes, regarding to what she just asked.
Yes, it's regarding the question.
Okay. I'm all ears.
Okay, my understanding of factor is that it's like a gradation, a spectrum of variables from one end to the other. I don't know whether it's accurate. Thank you.
Okay, so for me, is it that we use factor only for ordinal categorical variables? Can we also use
exactly?
So that's what I want to get.
We use it for ordinal data that are structured. They have structure. They have level. Okay, let's take university for example. We have year 1, we have year 2, we have year 3, and year 4. So they are variables that have levels. They have levels. They are ordinal. They are category. They are ordinals. So let me just tell you something. You can still tell R that, okay, you can tell R, you can specify how you want your levels to be. If R is not leveling it very well, you can just tell R how you want your level to be. In this case, I'm going to allow stage 1 to come first, comma, stage 2 to come second, stage 3 to come third, and stage 4 to come fourth. So once I've told her that this particular set of values, I want you to know that they are in levels, and this is the levels I'm giving to them. Once stage 1, stage 2, stage 3, and stage 4. Once you run the code chunk and you still call out levels, you are going to see 4 levels. You are going to see 4 levels. So cancer type. So once you want to check the number of levels. Like you don't want to check the name of levels. You don't want to check the number of levels. You are going to do that by just putting n in front of these levels. So, and something again you can still do to you can do again is like you can change the names. Probably you can change the name by using label. You can change the name of level 1 to be, okay, let me just say beginning phase, level 2 to be more beginning phase, level 3 to be more deadly, and level 4 to be most deadly. Like just to like tag them that, okay, once someone is having stage 1 cancer, is less complicated. Stage 2 cancer is becoming more complicated. Stage 3 cancer is becoming more complicated, and stage 4 cancer is most complicated. I don't know if you all get that.
Yes.
Okay. So, ma'am, did I answer your question?
Yes, you did.
Okay. So can we move on?
I raised my hands up.
Oh,
Can I?
okay.
Can I? Okay, so I want to ask.
Yeah.
The quite a number of what will I call them? Do I call them variables or factor, vector, lists, levels? There's even structure, STR. Because I want to know, like now between lists and vector, when do you use lists? When do you use vectors? Because they're quite. I think they look quite similar. So factors. I see that you put C before the bracket and you write your list of variables. Do you have to put C before each variable? Or also when we are putting things in order, do we have to use order, or do we have to use square brackets when we are putting factors? Because I just want to know so that in case you want to write a variable or you want to write a code in terms of analysis, when do you use a factor? When do you use a list? When do you use a vector? I just want to know. Thank you.
Vector, you use a vector, you store your variable in vectors is when you have the same values, like okay, the same data type. Probably all the data type they are qualitative, you can store them in a vector. When all the data type they are quantitative, you can store them in a vector. But once you are using list, that is, you are combining different vector and different data type. You are combining qualitative, quantitative, logical, integer. You are combining all the whole stuff, all the whole data type the whole data structure we have in the world. You are combining them together. Different data structure. That's when you can use list. And this factor is when you have a data that they have structured. They are in orderly manner. They're in orderly manner. That's why I use a stage of levels of cancer, like stage 1, stage 2, stage 3, stage 4, to do an example. And the reason why I'm putting C after this factor is that to tell R that, okay, this is the list, like this is a vector. Like it's just like, okay, I'm coming. Probably let me do it this way. Let me just say, okay, cancer 2. Let me just say cancer 2 equals to, I'm coming. Let me just copy. Probably you are going to get this. You are going to get this better now. Let me just copy this. Let me paste it here. So I said, okay, cancer 2. This is cancer 2. Cancer 2. I put cancer 2 in a vector, right? I now say, okay, cancer 2 still equals to factor of cancer 2. That is, I'm telling out that this cancer 2 you are seeing is it's a categorical data. It's our structure. It's in an orderly manner. So this is just simply what this C you are seeing here. This is a vector. Now applying these factors to a vector is telling out that, oh more, this thing where you see, it's an orderly structured data. I don't know if you get that.
Yeah, makes sense. Makes sense. Makes sense. Makes sense.
Okay.
Thank you very much. Makes better sense now. But okay, there are different other calls that will be used, or like others structure. Are you going to call them like STR? Will it be needed? You want to put
No,
them in structure?
no. When we don't have to rush things. When we get there, you are going to. I just have to just take this thing bit by bit so that you are going to understand it, every bit of it.
I appreciate you. Thank you.
So, so now
Excuse, sir.
we are moving to. Okay.
Yeah, my question is when you put stage 1 and stage 1, but when we print it or when we see the list, we have only like stage 1. So means when we have duplication, it will not show or what?
No, when I call out the levels, okay, I just want to know like how many levels do we have in the data. So it's showing that we have 4 levels. No matter how replicative the data can be, it's going to show you the number of levels you have. But if I want to call out, if I want to see what is in actually in the data itself, I'm going to like call out the function cancer type, either by using print cancer type or normal cancer type. So you can use it. It's going to write
So
the
this one
whole.
only the labels that we categorize. Okay.
Yeah,
Okay,
the
thank you
levels will
so
show
much.
you the categories and the levels they are.
Thank you. Thank you.
So and know if you want to know the number of levels, it's just by you to just add n to the levels. So that's just it. So now I think we can move forward now, right? Hello, can we
Yes,
move
let's move
forward?
forward. Yes.
Okay. So we are talking about data frame now. Data frame. Data frame is a structure that organizes data in a 2-dimension table of row and column. When you have I know like most of us here we are Excel users. You are going to notice Excel data are in rows and column, SPSS2 rows and column. So any data structure that is in form of that organizes data in rows and column in 2 dimensions, that is row and column, they are called data frame. So they are called data frame. So I asked someone to hold his question, to hold his question. I asked someone to hold his question. So let me say, okay, we want to create a data frame. We want to create a data frame. Let's just use 5 samples, 5 values. For example, let's use age equals to column 20, 25, 26, 30, 2, 3, 4, okay, 43. I run it. Okay, name equals, let me just see, name of student. Let me just rename that. Let me just say age of student. Do you know something about R is that now let me just explain this briefly. Okay, I have a data structure. I have a variable called cancer type, right? If I now like come to another chunk and create another variable in that variable name, it's going to automatically overwrite the previous one. It's going to overwrite the previous one. So if I have the age of student previously. So now that I'm creating another variable in the name of age of student, it's going to overwrite the previous age of student. It's going to overwrite the previous age of student. So name of student, just go again. Dan, tag, Jim, Kim, and T. So let me run this. Let me look for what else can I look for? Okay, let me just say gender of the student. Okay, let me just say gender of the student. Okay, let me just see, what else can I look for? Okay, let me just say gender of the student. Okay, let me just see, gender of the student. Okay, let me just see, gender of the student. Okay, let me just see, gender of the student. Okay, let me just see, gender of the student. Okay, let me just see, gender of the student. Okay, let me just see, gender of the student. Okay, let me just see, gender of the student. Okay, let me just see, gender of the student. Okay, let me just see, gender of the student. Okay, let me just see, gender of the student. Okay, let me just see, gender of the student. Okay, let me just see, gender of the student. Okay, let me just see, gender of the student. Okay, let me just see, gender of the student. Okay, let me just see, gender of the student. Okay, let me just see, gender of the student. Okay, let me just see, gender of the student. Okay, let me just see, gender of the student. Okay, let me just see, gender of the student. Okay, let me just see, gender of the student. Okay, let me just see, gender of the student. Okay, let me just see, gender of the student. Okay, let me just see, gender of the student. Okay gender of student. Gender of students. Because gender, let me just say this one is male. This one is male. This one is male. This one is female. This one is female. So once I run the first, let me just run the 3 codes line. First one, the name, the second one, and the third one. So I want to create a data, okay, let me just say data dot student equals to, you are going to use the function called data dot frame. That is, you are telling her that I want you to put these variables in 2 dimension, rows and column. So let me say the name come first, name of student come first, comma, age of student second, and gender of student. So once you click enter, you are going to see it's not going to run anything. But once you call out the function, the name of the data dot student. So can you see it creates it in form of row? That is, this is the rows. Daniel, age, this is Daniel. The name of student, first student is Daniel. Age is 20, and the guy is a guy actually. The second one too, thank, we have age 24. So this is how to form a data frame. This is how to form a data frame. This is how to form a data frame. So I ask someone to keep. So if you want to like view this, you want to view this, you want to view it, there is a function we call view. Let me show you what it does. View data dot student. So can you see it shows it exactly like the way Excel is going to show you, in form of row and columns, in form of rows and columns, in form of rows and columns. So, and another way is that you might decide that okay, you want to create your variables. You want to create your variables in a straight manner. Okay, let me use the example. Data dot student 2 equals to column, combine, sorry, not column, combine. You're going to say age of student equals to, we're going to use this C again. Oh, sorry. This should be data dot frame. Yeah. So we are going to specify age of student equals to, we are going to use equals to here because you are assigning this particular value. This value is already, they are in data frame. So you are assigning them those value to this particular variable name. So you are going to use equals to here. You are not going to use assignment operator. Please just take note. Once you are creating a data frame, let me just come here and copy this. Just say come here and copy this. Command name of students equals, just come here and copy this. Comma, and gender of student equals yep. So once you run it and you say okay, call out the you are going to see, can you see? So once you view, let me view this data to view data to, can you see? It does the same thing data one does, but the difference is that the way I placed it, you notice in this data one, in this student data one, name come first. This place, age of student comes second, and age gender of the student come third. And in this case, age come first, name comes second, and so that's how. So you can create your data frame in this manner or create it in this manner. So please, and also you can merge two data frames together. Once you have a data frame, once you have a data in form of row and column, it's very easy for you to manipulate the data, to play around the data, join the data, unjoin the data, do different kind of things, filter the data, and do all those. So you can subset the variables. So please, are we cleared?
Yes, I have a question.
Same here.
Okay.
Okay, and the question is from the two examples you gave on the creation of the data frame. So it presupposes that the second example, if we don't have the name of the student, the age of the student, and the gender of the student established, we can establish it using the second one.
Exactly.
Thank you.
Exactly.
So I have a question.
So okay, please can you
Yes.
go on?
So my question is about the initial code that was given to us. So the line 153, I don't know what it will be in yours, like the initial data code for the data frame. I've tried to run it to get the table, but it doesn't bring out the table for me with L3, FAC, and D. Yes, yes, your line 174, 175, and 176.
I run it and it worked. Can you see?
Because I tried for, I don't know why mine is not running on my own laptop.
You might have hit one error. Probably might have probably misplaced a parenthesis or something you have to like.
No, it's not stating an
just
error. It's just blank. I don't know.
It's just and the reason why it's blank is that if you run this first one, we're going to notice it's going to be blank because we are assigning these values to L3. If you run the second one, it's going to be blank because you're assigning these samples to these factors to this variable name fact. If you now come here and say D assigned to data frame into bracket x1 equals 1 x equals 1, y equals 1 to 10, and this fact is going to join all these you have done together. It's going to join them together. So if you call out this function by writing print D, you are going to have, it's going to bring out results. Or you just call out D alone, you are going to have your result. Check.
Okay, let me check and see.
Just call out the variable name D.
Okay, it's worked now. Okay.
Yeah.
Yeah, thank you.
So now, can we move on?
Sorry, before you move on, in the letters that I called, you used square brackets. Why did you use square bracket? And two, data frame, can we replace, when you want to write data frame, do you write DF? Sorry, I like to find the lazy way out. Does DF and data frame mean the same thing?
I think you are bringing that idea from Python.
Okay, sorry. Yeah, I got, yes.
So
Sorry.
R and Python are two different things. Yeah, although they are programming languages, but they are two different entities. So once you want to create a data frame, you must use data dot frame in R.
Okay. So in the line code 174, L is letters square brackets 1 3. Why did you use square brackets? I'm sorry, I missed that part. Sorry.
Okay.
I noticed earlier code we used mark curve brackets. I was just wondering why. I know you meant something, but I can't remember now.
Dr. Abioye, please, are you on the call?
Please, while you're answering, can you also interpret what those lines mean? Because I don't know what that L3 means, FAC. Like, what's the meaning of the code L3, 10 replace equals to true. If you could just read in plain English.
Okay.
I
This
think
L3
I think
equals
that L,
okay,
that
yeah.
L1
Okay.
to 3
I
means
have the solution. I have the solution. Can you hear me? So
Yes, Chief.
you see this
Yes.
L3. We said once you use the word 1:3 in R, it's telling you that if you list 1, 2, 3, the first 3 elements, can you see 1, 2, 3? So we are telling R that we need first 3 letter, which is A, B, C.
Okay.
If I call out L3, you're going to see A, B, C.
Okay,
We
sorry,
told him
sorry,
letters.
sorry, Chief. Sorry to cut you. I'm so sorry. Do
So
you mean some rows and the first row, or is it? Do you mean the first in a data set of let me say a factor, a combination of 0, 1, 2, 3, 5, or Tolu T Bayo. The first number is 0. The second one is 1. Third one is 3. Or is that what you mean, sir? Or is metrics?
Using this letter, using these letters is actually telling. Let me call out the data frame itself. Data frame itself. So can you see? It's actually telling. We are telling this one is just like we are using it to create something. We are telling R that we need 3 letters. That R should generate 3 letters for us. 1:2. So you see, A will take the position of, if I change this to ratio 4, we are going to see it's going to include C coming. Let me just change it to ratio 4 and let me run it. Can you see? It's going to change. You see, it takes it up to D because I shift it to ratio 4. So you are telling R that you need the first 3 alphabets, which is A, B, C. I want you to assign the first 3 alphabets to this variable L3.
That's taken. Can you go to the next code?
So the next one now is now telling this one, like this function, you don't really need this function. This function is telling this sample is telling R that I want you to sample this first 3 alphabets into 10 places, and replacement should be true. Sampling with replacement. So that's what it does. So we now
would it take the 1:3 and do it in 10 places?
It's going to take, we say 1:3, that is, we need the first 3 alphabets when we use letters. So it's going to like bring 10 samples using A, B, and C. It's going to bring 10 samples, like it's going to generate 10 samples with replacements, bringing A, B, and C. So that's the reason why when you do this, when you run this, and you print out this, you are going to see that it's going to, can you see A, because the without with replacement is what is true. It can replicate any figure. It's true. You don't really need that. My own now, like, is for you to just get the concept of creating data sets and data frame, because taking you through this rigorous stuff now, like, you might get confused.
I think it's quite confusing, because if you ask me, I thought it was going to say ABC, 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 and AB, or A.
When we are
so
let me make it more interesting. Okay, we have three alphabets on the table. 3 alphabets on the table. ABC. And I told the student that go to that table and randomly select 10 samples with replacement. So once I mix the alphabet together and I pick the first one, I pick A, I'm going to return it back to the table and mix it again and pick it again. So there is probability that I can still pick A. That is why we call it sample with replacement. If it's without replacement, now it's like when I removed A, I'm not going to return A. A is out of the equation. I don't know if you get that.
Okay, you're talking probability now. We get it in terms of probability.
That's why we are using sample. This sample is telling you that we want to create a variable name called fact. We want to create a variable name called fact. So, and this fact, this L3, we have already stored this L3 that we need the first 3 alphabets, which is ABC. We want it to create how many samples? That's 10. And replacement, that is replacement should be what? Should be true. We now come to the next line and tell you that variable D assign operator to data frame, X equals 1, Y equals 1 ratio 3, that is going to give 1, 2, 3, 4, 5 to 10. And we merge it with, we include this our fact variable. So that's why we are having, once you, okay, let me view this. Once you say view of the, can you see, it's going to bring it in form of row and column. This is not simply what you're just doing. So can we continue? Do you all get that?
You're trying to get it.
Please, you can
You are still-
continue.
Go on here.
It's very simple. The only thing is there that, but you got how I created this student data this student. You got that right.
Yes, those ones are understandable.
Once just hold down those ones, leave these ones. I know, because the word of these letters and sample is kind of confusing, that, but I've explained. This one is sample, so you don't really, at this stage, you don't really need sample. You don't need sample. And this letter is just telling you that L3 should be first 3 alphabets, which is A, B, and C. And this sample is telling you that between that A, B, C, select 10 samples. I want 10 samples with replacement. That is, if I pick A, I can still return it and still pick A again. I can still return it and still pick B again. I can still return it and still pick C again. They have equal chance of being selected at every selection process. That's what it just means. That's what that code means. But you just have to just leave that for now. So can I continue?
Please continue.
Please continue, please.
So the R ecosystem has inbuilt data. It has inbuilt data that you can use to practice your data. So once you click on data into brackets, can you see the list of data? These are the list of data. It has many data. Even if you import, if you install more libraries, you are going to get more data. Import more libraries, you are going to get more data. So that's what that is telling us, that you can just use those data to practice at your own leisure. You can use those data to practice at your own leisure. Let's check something. I want to check something. So if you like, okay, if you want to call out data now and you use your data, once you click your data, you just open your data and you are going to see it's going to bring the list of all the data sets in R, in the base R. It's going to list all the data sets in base R, all the data sets in base R. So you are going to just use the function called data, open bracket and close brackets. That's just it. Data and the 2 parentheses. If you call out only this, if you just only write the data, you won't get anything. You are going to bang into error. So you have to put those parentheses. They are very, 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 they are very, very important. They are very, very important. So to show you, we have one data we called CO2. Let me show you the data in R. Promise. Data cause CO2. Can you see this is the data? Let me call out CO2. So can you see the data? Let me view the data so that you can see it properly. Oh, okay, I can't view. I can't view this data. So it's not in a data frame, so I can't view it. So the best thing is just to call it out. So this is it. I've called it out. He has months, and he has years. So this is the CO2, like CO2 is actually a chemical element. I think is it oxide? Yeah, I think it's oxide. Sorry, I'm not a chemistry student,
Carbon
so
dioxide.
probably
Carbon dioxide.
carbon dioxide. Thanks very much. So carbon dioxide, I know it's something oxide. So now I've called out this CO2. So I want to just plot. Let me just use plot to just show you what is going to happen. When I click plot CO2, you are going to have this. It's going to plot that data. That exact data we are seeing is going to plot it. So are we all cleared? Can we move on?
This is an image data for R. We are just using it as an example.
Yes. You can use it at your own lecture to practice whatever things you want to practice. Can you hear me? So you can just use it to practice. We have hundreds of data. You can just use them to practice at your own lecture. That's just what it's meant for. So I can see someone raising his hand. Ogun Dikpe, please. Can you go on with your question? Oh, it's like he's not having any question. So let's move on. We are really behind time. I say I've spent your time.
Sorry, please. When are we rounding up? Rounding off exactly? What time?
No, I should. Yeah, I'm going to round up now. Let me just run the rest. I'm going to round up. Let me just say 9. Let's just say 9. The next 10 minutes, I should. Okay, 9 minutes
Because it's
already, but let
getting
me just round up.
complex actually.
Okay. Probably I'm okay. I'm very
No,
sorry if you are finding it very hard to catch up with my lecture, probably the way I explained. But
no,
I
not the way
just
you
want you to
explain.
just
Some of us are just we don't know anything from the basis, okay? Unlike the people that were
okay.
trying to catch up with you while they are doing it on their system. Okay.
I'm going to share a story after this lecture. I think that should cheer you up.
Okay, good. Thank you so much.
So we have libraries. We have several libraries in R, because we have the base R. The base R is when you want to be doing things on your own with R, and that might be it's going to, like, you might be very grounded in R before you can use the base R perfectly, like doing some complex things. So those that built R, they have come together to build some packages that can do those rigorous complex analysis for us in the tickle of an eye. So we call it, if we want to use a function, a package in R, we have something we call library. So once you want to install a package, when we start the class proper, you're going to know you're going to know what those libraries are meant for. Those packages are meant for. So once you call the function library, the library that is you want to call out, you have already installed a package. You want to call out the package from the installation box. You like the installation box? Let me just use that word. Permit me to use the installation box. Once you come here, you're going to see packages. These are the list of packages I've already installed. Is going to pop up here. The list of the packages I have already installed is going to pop up here. It's going to pop up here. So it's taking time to load. Let me just leave it. So I can just call out anyone. So I'm going to use the function called library. So, however, Crane has over 4,000 packages that are not included in the Bizarre installation. That is, once you download R, there are some packages that are not in the Bizarre. So you have to install them. So if you want to install that package, if you want to install package, you are going to use the function install dot packages. Then you are going to put it into into this, and the name of the package But you are going to need an internet connection actually to install a package. You're going to need an internet selection to install a package. So you are going to use the function. So that's what it works for. So if you want to get help, probably you want to use a factor, a function like that factor that you are kind of confused. Once you just come and put question mark factor and you run it, it's going to open every note, like every documentation about factor. What you need to know about factor is going to tell you. We are going to read through the documentation. This really help. This help function really help. Even me, I still use F function very well. I use it than any other person. I use F function. If you don't want to use question mark, you can just say help into bracket factor. It's going to still do the same thing. So can you see? So this one we are saying help. It should tell us how to install packages. That's what this help actually does. This one help does. So I was saying something that we were using R Markdown. So that is why the normal script for R is this, but this is an R Markdown. What this R Markdown does is that you can probably, I'm working, we are team. Okay, we are team now like this. So I'm working. Someone is to do the write-up and I'm to do the analysis. So we can work with R Markdown file. So I can share the R Markdown the file with my colleagues. So once I share the R Markdown file with my colleagues, it can do some analysis on its own ends, and we can print the analysis in form of PDF. We can print it in form of HTML, in form of Word. If I need this now, let me just need all this code in form of words. If I need them in form of words now, you're going to see, okay, we run out a code. I think there is a problem in one line. There is a problem. There is a problem. There is a problem. There is a problem. Come read out. So code 90, line 90. There is an issue with line 90. So it could not run. It could not run the analysis. I'm coming. Oh, can you see the J? I said if a particular stuff is not there, so it's going to give issue. So let me try to rerun it. I just want to show you the output. So 377. So if you have error, you are going to bang into serious issue. You have error, okay, because I've not installed this. So, but you can just list it. It's actually good for academicians, those that are in the academic, scientists, to use this R Markdown. So R Markdown. So R Markdown to us the way you can use R Markdown. It tags the header. Once you are talking about the header, you are going to use one hash. Talking about this two header, you are going to use header 2. You are going to use 2 hash, 3 hash, like that. So I'm not going to like explain this because we have consumed most of our time. I'm not going to really explain this, but in subsequent class, I hope you are going to catch up with R Markdown. It's very, very simple to use. R Markdown is very simple to use. So let me just okay. Something about working directorate. Let me just go and talk about working directorate. I think that's the last for this night. Working directorate. That should be the last for this night. So working directorate. Working directorate is actually the folder you are working with. Actually, I'm working with this folder called Start Clinic in Documents on my PC and in my user. If you try to run this set working directorate at your hand, it's going to give issue because the file we sent out is reading another working directorate. So which is not on your system. So you can set your working directorate by either coming to this section, you link up with your section and choose directorate. Once you choose directorate, you are going to navigate to where the file is. You're going to navigate to where the file is. If the file is here, you're going to navigate there and you're going to click open. That is, you have set your working directorate to be the working directorate you want to work with. Working directorate is actually a file combined of your data. You have your data, your R script, everything, so that you can stay organized. That's what working directorate works for. You have a particular folder you have already stored all your data. So you want to work with that directorate, because if you are not in that directorate, you will not be able to call out to read your you will not be able to call out your data from that file. So that's what working directory work for. So it's better for you to set your working directory. In case you don't know the working directory you are working with, you can just say get working directory WD, get WD. Once you click on the WD, it's going to show you the working directory you are working with. If you just try that at your own end, it's going to bring the working directory you are working with. So if you want to like import, please can you just give me 5 more minutes? If you want to import your data from from Excel, your data from Excel, neglect this one I used. So let me just say df equals, you are going to use, that is, I'm telling how that this df will be the name of the data I want to import. I'm going to read dot, okay, if the R file is saved in CSV, is it commanded limited limit or waiting they call it, that here just has a particular meaning.
Comma separated value.
Exactly. Thank you. Thanks very much. Command separated value. So once you want to import your data from command separated value, you can just use this like CSV. Then if you know the name of your data, I have one data called resident doctor dot CSV. So could not find this read. Okay, do you know this why I could not find this read? Because I need to install to load a library called readr. That is telling you that okay, I want to read Excel. You cannot read Excel file in the base R until when you call out this function. So once I run the code trunk, going to see okay, there is a problem. I think I run into problem. So yeah, so I use dot here. Let me try that underscore. Let me see something coming. Let me just try that underscore. Yeah, okay. Dot. Something is happening. Okay. It's like okay. Oh yeah. You called it out. Yeah. So you can use underscore or you can use dot. Data frame assigned read dot CSV dot resident doctors dot CSV. So actually you can use dot and you can use underscore. So I think we all get that. And you can use this one as well, but this one is like you have to go and copy a folder part where the data is and paste it here. And you can also load data from online, directly from online. Probably next section we're going to try that. If you want to load data from SPSS, we have a library called Avon. So you are going to load that and you can practice the same way I did it. Like I did it. We're going to say data underscore read underscore SAV into brackets resident doctors dot SAV. So something is happening. Okay, I did not load the, if you not load the library, you're going to run into error. So I have the data already. Once I call out the data, you're going to see the data here. So that's it. So you can as well load, you can write data into another okay, if you are created a data frame, you can write it into Excel, you can write it into R. So I would like to stop here. So we have some other things. These things are very straightforward. Okay, the rest are materials that you can use to like build your skills, your R skills, and your statistical skills. They are provided also in the script, so you can check them at your own convenience. So at your own convenient time. So I think with this, I've come to the end. So I can see someone raising hand. Ogundipe, please, can you go on with your question? So it might probably be a mistake.
Yeah, it's
So
been using it since we started. I think.
so I have come to the end of today's section. I'm very sorry I've taken much of your time. So what I said I'm going to share is that actually I started learning R from this platform. I was just in your position. Let me just say 1 year ago I was in your position. I started learning R, what R entails from this platform. So, and if I could like in base of 1 year learn R, the basics of R and the intermediate level of R, and still come here and come and like teach the basis of R for statistics, I don't see what is stopping you. So it's just like a motivation. So it's not, don't see it as a very hard thing. It's just like just sit down with it, try to practice. Even if you start 30 minutes per day, you are going to get it. So that's just all. So I thank everybody for participating in this section, and I thank the organizer of the program. So I look forward to see you very often in our section class very often. So I think anybody does not have any question, any other question. So I will stop presenting. So you can just kindly exit the class. You can exit the class now.